Hello everyone. Welcome back to the course of data structures using C. This video is brought to you by Newton's group of institutions, Macharla. This is Yegireddy from the Department of Computer Science and Engineering. Now, let us see the third sorting technique, that is selection sort. The selection sort is the easiest method of sorting. And in this, to sort the data in the ascending order, the first element, that is the element with the index 0, is compared with all the other elements in the array. If the first element is found to be greater than the compared element, then what we have to do is we have to interchange them. So in this way, after the first iteration, whichever the smallest element is there, that is placed in the first position, that is with index 0. And this procedure we are going to repeat for the second element and so on. So the selection sort algorithm sorts an array by repeatedly finding the minimum element from the unsorted part and putting it at the beginning. And here the algorithm maintains two subarrays in a given array. One is the subarray which is already sorted, and the second one is the remaining subarray which is unsorted. So here in every iteration of the selection sort, the minimum element from the unsorted subarray is picked and moved to the sorted subarray. Now let us consider the unsorted array for our example, which is consisting of 5 elements, say 23, 15, 29, 11 and 1. So in the first iteration, the first element 23 with index 0, which is compared with the second element 15. And since 23 is greater than 15, they are interchanged. That is, the swapping need to take place. So now the first element is 15. Once after swapping, the first element is 15. So this 15 is compared with the third element 29. But 15 is less than 29. Hence there is no interchange or no swapping. So now the first element is again the 15. So here the 15 is compared with the fourth element 11, and 15 is greater than 11. So what we have to do? We have to interchange. That is, we have to swap 11 with 15. So now our first element will become 11. And this need to be compared with the fifth element, that is with 1. So now when we compare 11, 11 is greater than 1. So they have to be interchanged. So 1 comes to the first position, that is with index 0, and 11 goes to the last position. So here the process is repeated till the first element is compared with the rest of all the elements. And here during the comparison, if the first element is found to be greater than the compared element, then they are interchanged, else not. And at the end of the first iteration, if you can notice, the first element with the index 0 is holding the smallest element, that is the smallest number. So in this array, the smallest number is 1. So after the first iteration, 1 will come to the first position with index value 0. Now in the second iteration, which need to start with the second element. So previously we started in the first iteration with the first element. Now the second iteration will start with the second element. Now the second element is 23. So here the process of comparison and swapping is repeated. So here the second element is 23 is compared with 29. But 23 is less than 29. Hence no swapping or no interchange. Now the second element 23 is compared with the fourth element 15. And we know that 23 is greater than 15. So there is a need for interchange, that is swapping has to take place. So 15 will come to the second position and 23 will come to the fourth position. So it is like this. Now the second element 15, which is compared with the last element, that is the fifth element 11, and clearly 15 is greater than 11. So there is a need for interchange, and that is swapping. So 11 will come to this position and 15 will go to this position. So here we can see that at the end of the second iteration, the second element with the index 1 will be holding the smallest number in the element from the index 1 to 4. So from here, so already this element is been sorted. So from 23 to 11, that is index number 1 to 4, the smallest element is 11. So that 11, the smallest element will be placed at the second position, that is index value 1. Now coming to the third iteration. So here the third iteration need to start with the third element. So first iteration started with first element. Second iteration started with second element. Now the third iteration starts with the third element. And here the third element is 29. So once again, the process of comparison and swapping is repeated. So here the third element 29 is compared with the fourth element 23. So here we can see that 29 is greater than 23. So there is a need of interchange, that is swapping takes place. So 23 will come to this position and 29 will come to this position. So our array will be like this. Now the third element need to be compared with the last element, that is the fifth element. And here 23 is greater than 15. So once again there is a need for swapping. So 15 has to come to this third position and 23 has to go to the fifth position. So once after swapping, the array will be like this. So here we can see that at the end of the third iteration, the third element, that is 15, will be placed in the index value 2. So this is the smallest element of the remaining three unsorted elements. So 29, 23 and 15. So these two are already sorted in the first two iterations. So in the third iteration, from third element to the last element, the smallest element is 15. That 15 will be placed in the third position. So now coming to the fourth iteration. So now the fourth iteration need to be started at the fourth element. So here our fourth element is 29. So this 29 need to be compared with the fifth element, and we can see that 29 is greater than 23. So there is a need for interchange. So we have to do swapping. So 23 will come to this position, that is fourth position, and 29 will come to the fifth position. So here our array will be 1, 11, 15, 23 and 29. So we can clearly notice that if there are n number of elements, so in this case our n number of elements is 5, then we have to make n minus 1, that is 4. N minus 1 is 4 iterations. So only after doing the 4 iterations, the array will be in the complete sorted order. So we can say that if there are n number of elements, then after n minus 1 iterations, the array will be in the sorted order. So this is the simple logic what we are going to use in the selection sort. And using this, we have to write the algorithm that what we have to see. Now, coming to the time complexity. So here, the time complexity is order of n square. As there are two nested loops, what we are using here. And now coming to the space complexity, the space complexity is order of 1. So here the good thing about the selection sort is it never makes more than order of n swaps and can be useful when the memory write is a costly operation. So that's all for now. And if you like this video, please subscribe to my channel and press the bell icon for the latest notifications. For admissions, please contact 94944 70795. Thank you, Vanan.